Welcome. So, if you've ever worked with data, you know it's never just sitting in one neat little box, right? It's scattered all over the place. Well, the tool we use to piece it all back together, kind of like a jigsaw puzzle, is one of the most powerful things in the data world, the SQL join. Let's dive in and figure out how it all works. Think about this for a second. Ever wonder how an app can show your name right next to your order history? I mean, your user profile is in one digital bucket, and your order history is in a completely different one. Well, the magic trick that stitches them together, making it look all seamless, is a SQL join. It's pretty much the hidden engine running behind almost every app you use.
All right, here's the game plan for today. We're going to start with the why, the scattered data problem. Then we'll hit the big ones, inner, left, right, and full joins. After that, we'll look at a couple of special paces, and then we'll wrap it all up with the main takeaway.
Okay, let's kick things off with section 1, the scattered data problem. So you might be thinking, why not just dump everything into one giant table? Wouldn't that be easier? Well, not really. It would get super messy and really inefficient. You see, database designers practice something called normalization. Just think of it as good digital housekeeping. Instead of writing out information technology 1,000 times for every single person in that department, you have one table for employees and another one just for departments. It's cleaner, it's faster, and it's way, way easier to manage. But you see, this creates a whole new challenge. Your data is perfectly organized, but now it's in separate places. So when you need to create a report, how do you pull that scattered information back together? You need a way to connect the dots, and that is exactly what a join is for.
On to section 2, the inner join. This is the workhorse. It's the most common join you're ever going to use, and it is all about finding those perfect matches.
If there's one word you need to remember for an inner join, it's only. It looks at two tables and pulls out only the rows that have a match in both of them. If a record in one table can't find its partner in the other, it's out of there. No match, no entry. Simple as that. All right, let's imagine this. Your boss walks over and says, "Hey, I need a quick list. Just give me every employee's name and the name of the department they belong to." Easy enough, right? Except that information is split across two different tables. Time to put that inner join to work. Okay, so let's check out our data here. On the left, we've got our employee table. On the right, the department table. So how do we link them? Notice they both have that department ID column. That's our golden ticket. It's the bridge that's going to connect these two worlds. And boom, there it is. The inner join gives us that perfectly clean list. But hang on a sec. What's really interesting is what's not on this list. See any employees whose department ID wasn't in the other table? Nope, they're gone. And what about departments that don't have any employees? Also gone. And this is the key thing to get. An inner join shows you only the perfect intersection of your data.
All right, that brings us to section 3, left and right joins.
So your supervisor comes back, they look at the report and go, "This is good, but wait, some employees are missing. I need to see all of them, even if we don't have a department listed for them yet." And just like that, our inner join is too restrictive. The game has changed, and we need a different tool for the job. Here's a super simple way to think about a left join. It's basically a two-step process. First, it does an inner join, finding all those perfect matches. But then, it does something extra. It goes back to that first table, the left table, and it pulls in every single record that got left behind. And check out the results. Now all of our employees are on the list. But for the ones that didn't have a matching department, the department name is filled in with null. Now that null you see, that's super important. It doesn't mean something's broken. It's just the database telling you, hey, I looked for a match for this employee, but I couldn't find one. It keeps all the data from our left table no matter what. And a right join? Well, as you've probably guessed, it's the exact mirror image of this. It keeps everything from the right table and fills in any gaps from the left with null. So if your boss had asked, "Show me all the departments, even the ones with no employees," a right join would have been the perfect tool. Okay, section 4, the full join. So what if you need to see, well, everything? All the records from both tables, no exceptions. That's when you need to bring out the big guns. That's where the full join, sometimes called a full outer join, comes in. It is the most inclusive join there is. You can just think of it as a left join and a right join, happening at the exact same time. Its mission is simple. Bring back every single row from both tables, period. Okay,
Now we're seeing the whole universe. We've got our employees who don't have a department. You can see their department is null. And we've got our departments that don't have any employees. Their employee name is null. A full join gives you a complete audit of your data. It shows you what matches, but maybe even more importantly, it shows you exactly what doesn't.
Okay, section 5. Let's quickly touch on a couple of specialty joins you might run into for very specific problems, the self-join and the cross-join. First up, the self-join. This is a pretty clever trick for when a table needs to talk to itself. It's perfect for things like an employee chart, where you need to find an employee's manager in the very same table. Then you've got the cross-join. Think of this one as the brute force option. It takes every single row from table 1 and pairs it up with every single row from table 2. It can create absolutely massive results, so you have to be careful with it. Now, here's the secret to the self-join. It's not actually a new command, like self-join. It's more of a technique. You just use a regular join, but you pretend the table is two separate tables by giving it different nicknames or aliases. This little trick lets you connect a row in the table to another row in that exact same table, like linking an employee to their manager.
Whew, okay, that was a lot. So let's wrap this all up with a final takeaway and make sure these big ideas really stick.
Think of this as your ultimate cheat sheet. Inner join, just the perfect matches. Left join, all from the left plus any matches from the right. Right join, you got it, all from the right plus matches from the left. Full join, absolutely everything from both tables. Self join is a table talking to itself. And cross join gives you all possible combinations. See? The trick is just to know what question you're asking. That'll always point you to the right join. And before we go, I've got one last super important piece of advice. You might stumble across something called a natural join. Avoid it. Seriously. It tries to be helpful by guessing how to connect your tables just based on column names. That sounds nice, but it's incredibly dangerous because it can give you results that are silently, horribly wrong. The lesson is simple. Always be explicit. You tell the database how to connect your data. At the end of the day, that's the only way to be sure it's telling the right story.